Assalamu alaikum. Hello, everyone. Good afternoon. Sat Sri Akal, Namaste to all of my viewers who are watching this mathematics class. Uh, this is my third session, and today's topic, as I mentioned earlier, is going to be the laws of exponents. So I'm going to just write down my topic of the day would be So this is going to be my topic of the lesson today. There are different laws of exponents, and as everybody knows that we were discussing our exponents topic in our previous sessions, and I'll just like to remind everyone to just log in if they are watching this live. So there are different laws. The first one is we call it multiplying power law. The next one is dividing power law, and then another one is exponent of zero law, and then we have power of a power law. So the first one I would like to explain is going to be our exponent of one law. So exponent of one law as it's obvious from its name, that exponent of one law means any exponent which has power 1. So we can give example of x power 1. So anything which has power 1, not 0, not 2, not 3, just 1, we normally ignore writing 1. So we can just call it x. Or you can say 2 power 1, we can call 2. Y power 1, we can call y. So it doesn't matter whether we are using a variable, we are using a digit, anything which has power as an exponent 1, final result is 1. Today, once I finish this lesson today, I'll also like to go and explain some of the calculations we have. So now the next was multiplying power law. So multiplying power law is as obvious from its name. When we have two different exponents and they are multiplying with each other, how we are going to manage. Remember my previous lesson when I explained, anytime when you see that you are going to multiply these exponents, you need to make sure you can only multiply, or these exponents can only be merged if the base is same. We cannot merge x to y or y to z. Their exponents cannot be, we cannot solve their numbers, or we cannot calculate, or we cannot merge their number. So the example we have given here is, for example, if we have one exponent x and the exponent is m, then we are multiplying another exponent and it has another power n. In such situation, as the base is same, exponents can be added. So we are going to add their exponent. So in this case, this is going to be like this, m plus n. So that means when your base is same, the exponents going to be get added. Now in simple mathematical number which make more easy to understand, say exponent was 3, sorry, and then exponent has x exponent 2. These can be written as 3 plus 2, and our final result would be x power 5. So that's a simple thing. Exponent law 1, simple is when your power is 1 or exponent is 1, it just become simple without any exponent, and we can write down as it is, like x, y, z, 2, 3, 4, 5, any digit. On the other case, when we are talking about multiplying of power law, so in this multiplying power law, when the exponent bases are same, and if you are multiplying them, the exponents get added. I gave you a simple example to make it more clear: x power 3, x power 2, and then because they were same bases and we were multiplying them, in such case, we can add their power. But if they are getting added, like x power exponent 3, and then we are adding, for example, this, no, we cannot add them. First of all, they are different exponents. They are not multiplying. So in this case, we cannot write them x power 3 plus 2 or x power 5. This law is only when the multiplication is happening. And remember, if the base is same. If you are having here y, then you cannot add them. So this is the basic law of multiplying power law. The next, I will go to the dividing power law. So now dividing power law. Similar to multiplication, you will see similarities to this. If we say x exponent this and divided by x exponent n, in such case, there are different ways to write down. In simplifying way, the easy way I would say, we can easily write down this x power m or x power n. That's one way. But the purpose of us explaining the dividing power law is how we solve these exponents with each other when the bases are same. So instead of doing this, I will prefer to write down this way. So this would be x power m. Remember, when we are multiplying, the powers are getting added. When it's division, the denominator or dividing exponent power will get as negative sign. So we can write down this as, we can convert this one as minus n, and then it will be, because bases are same, so we can write down m minus n. So once I will again give you a simple example by putting actual numbers. So if we have x, say power 7 dividing by x power 3, in such case we can write down x7 into x minus 3, which can be written as x7 minus 3, and it will give me x raised to power 4. So this is how we calculate these exponents when we are dividing. Now, so far we have reviewed exponent of one law, then we reviewed multiplying power law in the previous presentation, and then the next one we just covered up is multiplying power law, is done, and now we are doing dividing power law. Now I will go to exponent of zero law. So remember the first one we said exponent 1 law, then this exponent 0 law. Obviously from their name, it's clear exponent 0 law means the exponent power is 0. So when the exponent is 1, that base stays same unchanged. So when we have written previously, I'm going to use a different color so to differentiate. Remember the exponent 1 law, we said it's going to stay same. X, if it was y, 2, 3, when the exponent is 1, it just stays same. Now, in this case, the interesting part is if the exponent goes 0, this base doesn't go 0. This does not change to 0. It stays as 1. Any big number, even if you are writing 450,000, anything bracket, exponent goes 0 means the whole value goes 1. So in such case, if we say 4, 1, if we say 700, exponent is 0, 1. So no matter what happens, what is the actual base? As long as the exponent becomes 0, the whole value turns to 1. So I hope that it explains you the difference between exponent 1 law. This is called exponent 0 law or exponent of 0 law. So far we have covered 1 law, 0 law, multiplication of exponents, and division of exponent. Now, the next part in this exponent is again very interesting, and we call this part as exponent power of a power law. Again, remember those words are the title, explain you most of the time it's actual what is coming. So power of a power law. So in such case, obvious name is x m, and then we have a bracket and it goes power is m, and then next power out of the bracket is n. In such case, remember the first one we were doing the additional one, so it says m and n, we were writing it as m plus n. When it was m divided x n, we said m minus n. Now in this case, base is same, but we have a exponent and then we have this power and then there's another power outside. I remember when I was in school or college, my teacher used to say, in such case, remember, this n is going to come and hit on the hat. So he was just making funny ways of his teaching. He said, this n is going to hit m first. So when it is going to hit m first, it is going to multiply and the result come as x m n. Now I'll explain you with a simple algebraic value so you will understand what it means. So if I have x or 3 and then we have exponent say 4, so when 4 multiplied with 3, our answer becomes 12. I hope this explained you the power of power law. So what we have discussed today, the first was in our law of exponent, the first law we covered is exponent of 1 law, which I explain here. If this was 1, this become x. Then we covered x 0 law, means if it was 0, it becomes 1. Then we covered additional, I would say, multiplication, which gets power added. Division, power gets subtracted. And then we have power of a power law. These powers get multiplied with each other. So these are the, say, 4 different laws we discussed, or 5, I should say, altogether different laws. And now I am going to, it's called power of a product law. Another one is power of a product law, which is almost similar to this, but you can call it as a different way, power of a power law, but the technical word we call is power of a product law. let me write on here, which we were saying here. We just said is so now we are discussing power of a product law. So in this case, say xm power is m. So when you have a combined base or two variables are multiplying and they have a combined power or exponent, this exponent will change into xm ym. It's not exactly same. In this case, we have a power of a power. Then it got multiplied. In this case, we have one exponent, but inside the bracket, there were two variables. Or in simple way, I can explain you say x, y, and we have power say 3. So I'm going to write down x3 and y3. So this is how this power of a product law. So these were multiplying with each other, and we have one common power or one common exponent. So in such case, we are going to write on this the way. So I am going to cover write on the summary here x y. Power was say m. It becomes xm and ym. So these are the different laws. So 1, 2, 3, 4, 5, and 6. So here are 6 different laws of exponents we have discussed today. Now, after discussing these laws, I'd like to give you some examples to understand practically how these laws work. Remember, anytime you are seeing any of these, you should be getting a clear understanding that we are talking about laws of exponent, and the names of these laws, simple from their calculation, is this is law, one law, exponent one law. This is called a multiplication power law. This is called a division power law. This is called zero law. This is called power of a power law. This is called power of a product law. So it's easy to remember in this way as well. Now let's go through some of these questions to understand this. I like to keep these laws on the side so we understand that how or which law we are applying. So the first examples I have in my practice book is to simplify this question. I am going to simplify this. Let me just see here. So the question is the simplified form of the expression. So in this particular question, basically what they have done, they have utilized different laws from these. So the question is, say, x 20, y 13, z 14 over x 17, y 12, and z 11. So I hope that all those students, or even some of the parents I know, they mentioned that they are interested in watching and understanding these, which would be great. So once you have this expression in front of you, the first thing you need to understand is utilize these laws. And we can use these laws. Remember, in this, I can show you that number 2 and number 3 law are going to be used. How? Like this. So I can write down x 20. This x move up, and I can say minus 17. Then I have y 13 and then this y is minus 12, z 14, and this z is minus 11. Remember why I have changed their exponents minus 11, minus 14? Because of these laws right here. So when the denominator value moves up, their exponent sign change. So now in next step, I can calculate x is 20 minus 17, then y 13 minus 12, and then z is 14 minus 11. And simple calculation, x remain 3, then y is just 1, and z is 3. Remember this law, we don't need to write down exponent 1. We can, when the question asks you to change this whole expression into the simplest form, so in such case, you are supposed to bring it to the as possible simplest form as you can. So if I write down like this, it might be okay, but examiner or the evaluator who's looking at this will understand that you do not recall this law and you did not change it to x or y. So I should be getting it to a simplest form like this, and then this is my final result. So I hope you understand x20, y13, z14, then x divided by x17, y12, z11. All I did is I moved these because they were the same basis. I moved them upward as a numerator and changed their signs. And then because the bases are same, I added them together, and final result was 20 minus 17 is 3, 13 minus 12 is 1, 14 minus 11 is 3. As I explained, this exponent of one law used. I'm going to change it to y, and my final result will be x3, y, and z3. I hope this explained you well. Now I'll give you another example. This board is always moving. The next question is, we are going to multiply two expressions. So this one is A5 B3. We are going to multiply this with A plus B plus AB. So the question is, we are supposed to multiply these two expressions. So I'm going to write down this way so you understand. Sorry. So we will multiply this. Remember these laws. If you remember these laws and you understand these laws, I don't see there should be any confusion. It's very simple and very easy. So I will just go step by step. I will not just skip the step. So it says A5 B3 into A. Then this whole A5 B3 is going to go inside and multiply one by one. It says A5 B3 into B, then A5 B3 into AB. So now simple, use these laws. In this case, this A and A are the same base. I have 5 and this one has 1. So I can add these ones. So I can say 5 plus 1 B3. In this case, I have B exponent 1 and this B has exponent 3. So I can add these ones as B3 plus 1. So A5 B3 plus 1. Then in this case, I have both A and B. So I can write down A5 plus 1 into B3 plus 1. Now A6 B3, this is A5 B4, this is A6 and B4. So this is our final result. Once again, I keep reminding you, remember these exponent laws. Remember by their names. Do not just go and try to memorize how it's done. Always go step by step, understand their names, and the actual function is explained simply in their names. Once you understand the names and their concept, these questions are a piece of cake for you, I can assure you. Let me see if I can have another example. I have another example which I can say is uh, the last one we read was product of exponent law. So let me just go through that. The question is 4x3 y8 over 2x5 and y6 3. So once again, if you remember, let me just double check that I'm copying it right, so I'm not doing any mistakes. Yes. So once again, remember these laws. If you remember these laws and you understand their basic concept, it should be an easy way. So 4 times 3 power 3 means 4 into 4 into 4. So then I am going to write down 4 into 4 into 4, and then remember this law. Sorry, number 5 is power into power, and then what we did, we multiply these exponents. So here I'm going to write down 3 into 3 and y 8 into 3. In this case, again, 2 into 2 into 2, x 5 into 3, and then y 6 into 3. Remember, these are not going to be add. Addition was when the bases are same and you are multiplying them. So in this case, what will be the answer? 4 into 4 is 16, and 16 into 4, 16 into 4, 64. X, this will become 9, this will become 24, this will become 4 to the 2 to the 4, 4 to the 8, this will become 5 3s are 15, and this will become 6 3s are. What is 6 3s are? I can't see on the Facebook, but at least 18. Now, do you see this is our final answer? No. Still, there are some more calculation and more simplification required. In this case, if I divide this by 8 is 64, so I left with 8. In this case, I will do the same thing I did in the previous question, and I can write down x 9 minus 15, and then y 24 minus 18. So now, what would be my answer? This would be x minus 6, and y, what would be my y 6? I can easily write down 8 y 6 over x 6, because I need, it's better to move it and make it a positive one. Either I can write down this way, or if somebody likes, they can easily write down 8 into y over x whole exponent 6, but I think this should be okay answer. If somebody else have any questions, please feel free to contact me or ask me any questions. Let me just compare with this. Okay, now there was one question. Let me see. So now there's another example. I'll just do this example, and we'll finish today's session after this example. So this question was, what is the simplified form of the expression? So expression is minus 2x 3 power 4. So in this case, remember, again, we will just review these laws. So in this case, this negative sign will remain negative. Always remember, this negative has a even number as an exponent. So that shows you that even number of exponent means minus into minus into minus. When you have even multiplication, it will change into plus. So this inside sign will easily be changed into plus sign. But remember, this negative change to plus, but this negative is going to make sure it becomes again negative because we have one negative sign outside. So what I'm going to do, I'm going to open this bracket. As soon as I open the bracket, this negative sign will be changed to positive. This 2 times 4 times 2 is 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. So this 2 will give me, let me just break it so you can understand easily. So I'll say minus 2 into minus 2 into minus 2 into minus 2, and then x power 3 into 4. I should not write down this bracket because bracket shows that yes, I open up the bracket. So I'm not going to write on this, but I'll just use maybe this to make it more easy to understand. This sign will remain here. So this negative into negative, positive, then negative, and then positive finally. So my answer would be 16. And here it would be 3 into 4, 12. This negative is still negative. And remember, this negative has nothing to do with this minus sign because this was outside of the bracket. This negative sign turned into positive because the exponent was even number. And when we have exponent even number, this means we are multiplying the negative by even number of means pair, and those pairs are making this negative sign as a positive sign. I hope in today's session I was able to explain this. Let me just give you another question for as a homework for practice question for you guys who are watching. So you do it and then you can easily share with me your answers on Facebook Messenger, or you can write down the answers on this comment box. So the question is, write down the simplified form of this expression. So this is 3x y square 3 into minus 4x square y divided by 2x square y square, and we have exponent 2. So this is my assignment question to all of the viewers who are watching this, all the students of mathematics who are watching. I hope that this session was informative for you guys. And remember to understand this, just a recap, we learned today the laws of exponent. We have power 1, we have multiplication, we have division, we have 0 exponent power, then we have this exponent above exponent, and then we have multiplication or product 1. So we got these 6 different laws of exponent covered. This is an assignment question. I have solved some of the practice question with you guys. I hope this was an informative session for you and you have learned something from this. Feel free to contact me through Facebook or through my phone number 416-571-1163, and I'll be happy to help you out in these sessions. Thank you and have yourself a wonderful day. See you next week. Next week, my topic will be, let me give you my next week topic. We have covered this, and now we will be going through multiplication and divisions and subtractions about operation with integers. So the next topic will be operation with integers, and in that topic I will cover some of this quadratic equation. Remember, I mentioned that quadratic equation is the first topic for grade 10. Now we are coming to a point where I can easily explain and use these laws while we are covering the quadratic equation, because without understanding these, it would be challenging for anyone to understand how these quadratic equations work. So once again, I hope it was an informative session for you guys. Thank you and enjoy your week, and see you next Sunday. This session will be going on every Sunday from 1 to 1:40 around this time. Thanks and have a great day. Stay tuned.